Hello and welcome to Maths with Jacob. This lesson will focus on factor trees. A factor tree can be used to find the prime factors of a number. So let's look at some examples to see how factor trees are used. Find the prime factors of each of the following numbers by using a factor tree. So the first number is 18. So we put 18 here, and then we put two branches. Now since 18 is an even number, we know that 2 divides into it, and we know that 2 is a prime number. So 2 times 9 will give us the 18. So we continue the branch down there and just write that 2. Now we have to find some numbers that are multiplied together to give us 9. Now 9 is an odd number, so we can't use 2, but we know that 3 times 3 gives us 9. So in other words, 2 times 3 times 3. And we have all those numbers there, and each of them is a prime number. So 18 will be 2 times 3 times 3, which is 2 times 3 squared. And that's our index notation that we saw in a previous lesson. Let's look at 40. So we put 40 there. Now 40 is an even number, so we know that 2 divides into it. So we have 2 times 20, that gives us 40. Now we put the 2 here. Now two numbers multiplied together to give us 20 will be 2 times 10. So we continue that 2 down there. Two numbers multiplied together to give us 10 will be 2 times 5. And we can't go any further. So we have 2 times 2 times 2 times 5. So 40 equals 2 times 2 times 2 times 5, and that's 2 to the power of 3, or 2 cubed, times 5. And 2 and 5 are prime numbers. 54. So we put 54 there. 54 is 2 times 27. We continue that 2 down there. 27 is 3 times 9. We continue that 3 down there. 9 equals 3 times 3. So we have 2 times 3 times 3 times 3. So 54 equals 2 times 3 times 3 times 3, which is 2 times 3 cubed. And notice 2 and 3 are prime numbers. So you notice how these are like the branches of a tree, and that's why we call it a factor tree. Just pretend this tree is upside down. That's actually the trunk or the base here, like that's the base, and these are all the branches, and the tree's upside down. Let's look at 60. So we're finding the prime factors of 60. So 60 equals 2 times 30. We know that because 60 is even. That's why we can put 2 there. 2 times 30. We continue that 2 down. 30 equals 2 times 15. We continue that 2 down. And 15 equals 3 times 5. So we have 60 equals 2 times 2 times 3 times 5. 2 times 2 is 2 squared. And then we have times 3 times 5. And they are prime numbers. So we've seen a process here in this slide, or in this video, where we use a factor tree to find the prime factors of a given number. So when we find the prime factors, we end up with numbers like 2, 3, 5. If the number's a larger one, we might get a 7. And then at the end, when you have the answer at the end, each of these numbers, that is, each of these numbers in the base, has to be a prime number. And that's the whole idea of the exercise.